Welcome back to today's Explainer, everyone. I'm absolutely thrilled you're tuning in. Today, we're popping open the Ultimate Coder's tool belt. Now, we're not going to look at Java operators as some dry, abstract academic concept. No way. Instead, I really want you to think of them as the physical, daily tools you'll reach for, day in and day out, to build incredible software. Whether you're a total novice getting your hands dirty for the very first time, or an experienced dev looking to sharpen up your daily workflow, really understanding these tools fundamentally changes how you write code.
Here's our roadmap for today. We'll start with math and value assignment, then move into making daily logic decisions. After that, it's quick code shorthand tools, bitwise and shift operations, operator precedents and rules, and we'll wrap it all up by nailing Java interview questions.
All right, let's jump right in. Just to make sure we're all starting on the exact same page, what actually is an operator? Basically, it's a special symbol we use to perform operations on variables and values. Take a look at that example. Int sum equals a plus b. See that plus sign? That is our operator. It takes the value of a, adds it to b, and spits out our sum. You can think of it as the verb in our programming sentence. It's what makes the action happen.
Section 1. Math and Value Assignment.
Now, what's really cool here is just how familiar these look. These arithmetic operators, addition, subtraction, multiplication, and division, are the absolute bread and butter of your daily math calculations in Java. You use these for literally everything, like building the math logic for a basic shopping cart algorithm. The only one that might look a little bit novel to you is that percentage sign at the bottom. That's the modulus operator, and it simply gives you the remainder of a division. So if you divide 10 by 3, the modulus is 1 because that's what's left over. Simple, daily math, executed perfectly. Okay, but what if we want to speed up our daily work? That's exactly where compound assignments come in. On one hand, you have your simple assignment using the basic equal sign just to give a variable a value, like a equals 10. But then we have these compound assignments, like plus equals or times equals. Guys, these are massive time savers. Instead of typing out a equals a plus 5, you just type a plus equals 5. It does the calculation and assigns the brand new value right back to the variable in one swift, elegant motion. It keeps your code super clean and your typing incredibly fast.
Section 2. Making daily logic decisions.
So, for a program to actually make a decision on its own, it has to compare things, right? Enter the relational or comparison operators. You can think of these as the logic gates of Java. They're constantly looking at two values and returning a very simple binary answer, true or false. Is A greater than B? True or false? Is it less than or equal to? True or false? Your program's if statements rely entirely on these little symbols to know which path to take.
Now, I really want to pause and strongly emphasize this next distinction, because confusing these two symbols is, without a doubt, one of the most common and deeply frustrating daily coding errors for beginners. A single equal sign is the assignment operator. It gives a value. So a equals 10 means make a 10. But the double equal sign, that's the equal to operator. It asks a question. A equals 10 means is a currently 10. Mixing these up is going to break your logic instantly, so lock this rule into your memory right now.
But hey, often just one single comparison isn't enough. What if you need to know if a user is an adult and if they have a valid ticket? That's where our logical operators step up. These work directly with our Boolean true or false values. We've got the double ampersand for logical and, which means both conditions absolutely must be true. Then there's the double pipe symbol for logical or, meaning at least one condition has to be true. And finally, the exclamation point is logical not, which just flips a true to a false or a false to a true. They let us build really complex, nuanced logic scenarios without breaking a sweat.
Section 3. Quick code shorthand tools.
Let's look at unary operators. Up till now, the tools we've used, like addition or comparison, needed two variables to work, an a and a b. Unary operators are totally unique because they only need one single variable, or operand, to do their job. Use a plus or minus sign to say if a single number is positive or negative, our logical not to flip a single Boolean, or the tilde symbol for bitwise complement, which actually flips the raw bits of a number. One operator, one variable. Easy.
Let's walk through this timing sequence visually because incrementing is something you're going to do in pretty much every loop you ever write. Look at pre-incrementing, written as plus plus a. This tells Java to increase the value by 1 first, and then go ahead and use that new value in whatever equation it's sitting in. Post-increment, written as a++, tells Java to use the current value for the equation first, and then increase it by 1 after the fact.
And by the way, that exact same timing logic applies perfectly to pre- and post-decrement with the minus signs.
Oh man, this next one is one of my absolute favorite shorthand tools, the ternary operator. Check out that syntax. Condition, question mark, value 1, colon, value 2. What this brilliant little operator does is condense a bulky, multi-line if-else statement into a single, highly elegant line of code. It basically asks a question, the condition. If it's true, it assigns value 1. If it's false, it assigns value 2. It is ridiculously efficient and makes your code look so clean.
Section 4, Bitwise and Shift Operations.
All right, let's look under the hood a bit. These are the bitwise operators. You'll notice they look kind of similar to our logical operators, but they're just single characters, a single ampersand for and, a single pipe for or, the caret symbol for XOR, and the tilde for not. Now these operators actually bypass that high-level true or false logic we talked about earlier. Instead, they line up the actual ones and zeros, the raw binary bits of two numbers, and perform operations directly on them. It is fundamental machine-level manipulation.
Building right on top of that, we have shift operators. These guys literally take the sequence of binary bits that make up a number and physically shove them to the left or to the right. A left shift fills the new empty spaces with zeros, a right shift does the same thing, and an unsigned right shift guarantees that zeros fill in from the left regardless of the original number's sign. This drastically alters the integer's value, essentially doing rapid multiplication or division by 2 with maximum processing efficiency. Section 5. Operator Precedence and Rules.
Think of this as your ultimate rulebook, the operator precedence table. It ranks everything from highest priority up at number 1, all the way down to number 10. Notice how at priority 1, parentheses always went out. Just like in standard math you learned in school, whatever's inside the parentheses happens first. Then we hit our unary operators like incrementing, followed by multiplication and division, then addition and subtraction. As we move down the list, we get into our relational comparisons, logical ands and ors, our ternary shorthand, and finally, dead last at priority 10 is basic assignment. The equal sign happens only after all the other work is complete.
Section 6. Nailing Java Interview Questions.
So let me ask you, are you ready for your technical interview? Because let me tell you, interviewers absolutely love testing you on operators. It instantly shows them if you truly understand how the language works or if you're just kind of guessing. Let's look at the most commonly asked foundational operator concepts so you can answer them with absolute 100% confidence.
Here's a huge one, short-circuiting. An interviewer is almost guaranteed to ask, what's the difference between the double ampersand and the single ampersand? The answer, the double ampersand is the logical and it uses short-circuit evaluation. That means if the first condition it checks is false, it instantly stops checking. It knows the whole statement can't possibly be true, so it saves precious processing power. The single ampersand, the bitwise and, stubbornly evaluates both conditions no matter what when you use it with booleans. Interviewers are checking to see if you know how to write efficient code.
And that exact same logic applies when they ask you about the difference between the double pipe and the single pipe. The double pipe is logical OR, and it also short circuits. But get this, it stops if the first condition is true, because that's literally all it needs to validate an OR statement. The single pipe is bitwise OR, and again, it evaluates both conditions regardless. If you can lock in this understanding of efficiency, you are going to seriously impress any hiring manager.
And to wrap up our interview prep, here's that classic trick question we touched on earlier. What is the precise difference between pre-increment ++a and post-increment a++? Here is your bulletproof answer. Pre-increment increases the value first and then uses that newly updated value in the expression. Post-increment uses the original value for the expression first and only increments the variable after the expression is fully evaluated. It's all about the timing.
Well, there you have it. We've officially unpacked the entire toolbox. Remember, mastering these tiny symbols, knowing exactly when to use a logical operator versus a bitwise one, or really nailing precedence, isn't just about memorizing some textbook rules. It is the secret language to writing flawless, deeply efficient software every single day. These symbols are the absolute foundation of all software development. So my final question to you is, now that you know exactly how to use them, what are you going to build with your toolkit today? Thanks so much for joining me on this explainer, and happy coding.